During a phase change, we say that the Gibbs free energy or the reaction is at equilibrium, therefore delta G is 0 for any reaction at equilibrium. This allows us to isolate for delta H or delta S. Today we'll be using delta S. So we could see isolating for this would give us our change in enthalpy divided by our temperature. When we moved one of them to the other side, it got rid of the negative sign. Remember, the units for our enthalpy are typically in kilojoules per mole, and our units for entropy are typically in joules per mole Kelvin. So when we do this reaction, we want to make sure we convert one of the quantities to be the same, either joules or kilojoules. This question is asking for our units of entropy to be in joules per Kelvin. So we need to get rid of our moles somehow. Our moles on the left side are actually coming from the moles in our enthalpy because our temperature is in Kelvin, and here's where our energy per mole Kelvin is coming from. I'm just going to say that we have converted our enthalpy into joules, just so you can see more clearly that our units of entropy are coming from our units from the right hand side. So we need to just change the right hand side by multiplying by the number of moles. When we multiply by moles, that gets rid of the moles in our right hand side, and therefore the left hand side will not have moles in it. So we're going from a molar entropy to just entropy. So now the units would be just joules per Kelvin. Multiplying by number of moles is the same as mass divided by the molar mass. Molar mass we would get from the question or periodic table, but you know that. So this reaction changed. We started with molar entropy, and now we've gotten rid of the molar entropy, we're just doing entropy. And this is the equation that we'll use.